Welcome to EDU World Space.
So in this video, we're going to talk about question 26 from chapter 20, which says electrolysis of an alkaline earth metal, chloride, using a current of 5 amperes for 746 seconds deposits 0.471 grams of metal at an electrode. Is the metal deposited at the cathode or anode of the electrolytic cell? What is produced at the other electrode? What is the identity of the alkaline earth metal? So the fact that we have an alkaline earth metal means we're working with a metal that prefers to react to lose 2 electrons to form a +2 ion. And we're depositing the metal, so we're reacting M+2 to form M. And we also know that we can identify the cathode by where reduction is occurring, because reduction happens at the cathode, and we can identify the anode as where oxidation happens, because oxidation happens at the anode. So let's go ahead and write out the reaction for this electrolysis. So we have our metal chloride, and since our metal has a +2 charge because it's an alkaline earth metal, we know that the formula is MCl2. We need 2 of our -1 charge chloride ions to counter that +2 charge on our metal. And our products are the solid metal and chlorine gas, Cl2. So let's go ahead and assign oxidation states so we can determine what's being oxidized and what's being reduced. So we know that the oxidation state of our metal, when it's in our metal chloride form, is +2. It has a +2 charge on it. But then in the product side, when we have just solid metal, that's going to have an oxidation state of 0. So our oxidation state has been reduced from +2 to 0, meaning we've gained 2 electrons. So that's reduction. So that's happening at the cathode. What's happening at our other electrode? Well, we have the oxidation state on chlorine when it's in MCl2. It has a -1 charge, so the oxidation state is -1. Whereas when it's a product, when it's Cl2 gas, it has an oxidation state of 0. So the oxidation state is being increased from -1 to 0 because we're losing an electron. That's oxidation, is loss of electrons. So that's happening at the anode. So where is our metal being deposited? Our metal is being deposited at the cathode because that's our reduction half reaction. While at the other electrode, at the anode, we're forming chlorine gas. So that answers our first 2 questions. The other question we're asked is, what is the identity of the alkaline earth metal? So in order to determine that, we're going to have to solve this electrolysis problem. So we're told that we apply 5 amperes for 748 seconds. So we can take the amperes and multiply them by how long, by the number of seconds, and that will give us the number of coulombs of electricity that we have. So the number of coulombs is 5 times 748. That gives us 3,740 coulombs. We know that the half reaction happening at the cathode, our reduction half reaction, is our M+2 ion plus 2 electrons forming the solid metal. So this tells us that for every mole of metal that we're forming, we're consuming 2 moles of electrons. So that factor of 2 is very important. And 1 mole of electrons is equivalent to 1 Faraday of electricity. So if we're talking in units of electrons, we're talking about moles of electrons. But if we're talking about units of electricity, we're talking about Faradays. So 1 mole of electrons is equivalent to a Faraday, is the same thing as 96,500 coulombs. So we know how many coulombs we have, so we can figure out how many moles of electrons that gives us. So we have 3,740 coulombs, and we know that for every mole of electrons, we have 96,500 coulombs. So dividing those 2 numbers gives us 0.0388 moles of electrons. So we know how many moles of electrons we have, but how many moles of metal do we have? So we consume 2 moles of electrons for every 1 mole of metal that we form. So we take that number and we divide it by 2, and we end up with 0.0194 moles of our metal. So now we're told the mass of metal that's deposited on the electrode. and we just calculated the number of moles of that metal we have. So the mass divided by the number of moles should give us the molar mass, which is something we can look up on the periodic table. So mass divided by moles in this case gives us 24.3 grams per mole. If you look at the periodic table for an element with a molar mass of 24.3 grams per mole, you'll see that that element is magnesium. So the alkaline earth metal in this electrolysis reaction is magnesium chloride.